Now we have something a little bit different, okay? Instead of giving you an actual function, this says I'm giving you this derivative. So this is f prime of x, okay? This might be an example of, let's say, a non-calculator portion of the exam. So first of all, find all the critical points. I'm going to challenge you right now and say that there are 2 critical points here that you could find if you understand the meaning of a derivative is undefined, that you could find without using a calculator right now. Pause the video, see if you can find them. Well, hopefully you said, okay, well, whenever we get a 0 in the denominator, that means things explode. So basically, this derivative is going to be undefined. That's going to occur at x equals 0 for this case right here, and at x equals 1 in this case right here. Both of those values cause a 0 in those denominators. Things blow up, okay? So those are our first 2 critical points. Now the next critical point, we could go through just a horribly, horribly painful exercise in algebra to attempt to solve for that and find these. We'd have to probably use the binomial theorem somewhere in there too, which wouldn't be too fun. But instead of that, let's instead, if it's a calculator portion, let's actually graph that derivative function. All right, so the graph of that derivative function looks something like this. So remember, critical points are going to occur when the derivative is undefined. We actually just found those. X equals 0. It's a little bit hard to see, but that's a vertical asymptote. X equals 1 is also a vertical asymptote. So those are 2 places where the derivative is undefined. We just found those. Okay. Now, if we want to find where the derivative is defined, we can click on this guy right here, and we see, there we go, we got 1 point where x is equal to 1.85, where that crosses 0. For some reason, that isn't showing up very good on the video. Why is that line not showing up? There we go. Okay. So we have, highlight this. We have this value right here. So at x equals negative 1.85, the derivative is 0 again. And at x equals 1.75, the derivative is also 0. Okay? So in this case, we would have f prime of x is equal to 0, at x equals negative 1.85, and at x equals 1.75. All right? So those are our critical points. Awesome. So now what do you think is the next question I'm going to ask you? The next question is going to be, once the mouse wakes up again, I have a feeling we're going to be playing this game a lot going forward with the new videos. That's all the fun of improvising them, people. I never claimed that they were professional. All right, so now we want to find the maximums and minimums, okay? So if we draw our number line, this one doesn't have any endpoints, so we don't have to worry about endpoints. But we have negative 1.85 was on there. These are our x values. X is 0 was on there. X was 1 was on there. And x of 1.75 was also on there. So let's go back to our graph and let's see what this function would look like at those particular points. All right? So take a look. I would say, these are our points right here. Here's our first 0. Our derivative is negative to the left of it and positive to the right of it. So let's write that down on our number line. If a derivative goes from negative to 0 to positive, what does that mean? Look back at the last video if you need to figure it out. What you should have gotten is that when the derivative goes negative 0 positive, that means, and this is f prime of x, that means we have a minimum at that point. Okay? Now at x equals 0, our derivative was undefined. It was also undefined at 1. And it was 0, 1.75. So I'm going to put the screen back up here, and why don't you figure out what x equals 0 and x equals 1 and x equals 1.75 are in terms of minimum, maximum, or perhaps nothing. So pause the video on this picture, see if you can figure it out. All right, well, what you should have found is that to the left of 0, we already found our derivative was positive. Well, it turns out to the right of 0, it's positive as well. What happens when we have no sign change in the derivative around a critical point? It means it's just a critical point. It's not an extreme value, okay? However, this was x is equal to 1, our other critical point. Here, the derivative switched from positive to a negative value down here. So what we would have gotten was that x equals 0 was nothing. It was just a critical point, no extreme value. But x equals 1 would have been a what? What happens when our derivative goes positive, undefined negative? It's a maximum. Okay, so we get that's a maximum. And then we look at our final point of 1.75. The derivative switches from negative to 0 to positive. Okay, so if we look at this and add this to our number line, we got that it was positive, undefined, positive, then negative, then positive. So basically this one was nothing. This one, positive, undefined, negative, that's a maximum, and negative 0 positive is a minimum, okay? So our function would have had 2 local minimums and 1 local maximum and 1 critical point at which the derivative, or I'm sorry, 1 critical point in which we neither had a local minimum or a local maximum. So what we should do right now is let's hide this, and we have this big old nasty plot up here, but I'm going to replace that with a different plot. So the one I haven't shown is this. This red function is actually the original function, okay? So look at the original function on here. I'm keeping the derivative up here, so if you want to, you can kind of correlate the derivative to the function. At this point, we had the derivative go negative, then 0, then positive, so that's a minimum right there. At this point, at x equals 0, the derivative went positive. It was a positive derivative to the left of 0, and then it stayed positive. It was still a positive to the right of 0. So this was a vertical tangent. It was a critical point because the derivative was undefined, but it was neither a minimum nor a maximum because we didn't get that sign change. Then around x equals 1, we had the derivative went from positive to negative, so that's why positive to negative. This point was a cusp. It was where it was undefined, but it was where it was equal to 0. Then finally at this x value right here, the derivative went from negative to the left to positive to the right. So we had a minimum that was right there. And there we go. Again, by just analyzing the derivative, we were able to figure out where all those minimum and maximum points were of the original function. So that being said, we're going to go over several example problems of finding extreme values in class. So come with class tomorrow, ready with questions.